Hello there, and welcome to my channel. Tonight, we're embarking on a quiet journey through one of the universe's most elegant mysteries, magnetic fields, the invisible threads that weave through space and time, shaping galaxies, guiding particles, and orchestrating cosmic dances we're only just beginning to understand. Think of this as your gentle invitation to drift through the hidden architecture of the cosmos, all while staying perfectly tucked up wherever you are. Now, I should give you a fair warning. While this video is designed to help you unwind and settle into rest, there's always the small possibility that it might be just fascinating enough to keep you listening. But if you do find yourself wide awake at 3 in the morning, contemplating the magnetic field lines spiraling around distant stars, well, at least you'll have learned something remarkable about the invisible forces that sculpt our universe. Before we begin floating through these magnetic realms, I'd love to know, where in the world are you watching from, and what time is it for you right now? Whether you're tuning in during the witching hours, at dawn's first light, or somewhere in that drowsy space between, you're very welcome here. If you enjoy these peaceful explorations through science, please consider giving this video a gentle like and subscribing to the channel. It helps other curious souls find their way to these quiet corners of wonder. And just a quick note, while we'll be discussing magnetic forces, field lines, and electromagnetic phenomena, this video is purely for educational and relaxation purposes. It's not intended as medical advice or a substitute for professional care regarding any magnetic therapy or medical devices. If you have concerns about magnetic fields and health, please consult a qualified professional. So, close your eyes if you like, let your shoulders drop, and take a long, slow breath. Tonight, we're going to explore the invisible scaffolding of the universe, those mysterious magnetic fields that flow through space like cosmic rivers, connecting stars to planets, planets to moons, and all of us to the grand electromagnetic symphony of existence. Let's begin. Picture, if you will, the space around you right now. To your eyes, it appears empty, just air, perhaps some dust motes floating in a shaft of light. But in truth, you're sitting in the middle of an invisible ocean, a sea of magnetic field lines that stretch and curve through the room, through your body, through the earth beneath your feet, and out into the vast reaches of space. These lines are silent, weightless, and completely undetectable to your senses, yet they're as real as the chair you're sitting in and far more ancient than any mountain or ocean on our planet. Magnetic fields are, in essence, regions of space where magnetic forces can be detected, but that clinical definition hardly captures their true nature. They're the universe's way of organizing itself, creating invisible highways along which charged particles travel, forming the hidden blueprint upon which cosmic structures are built. Every magnet you've ever held, from the simple fridge magnet securing your shopping list to the powerful electromagnets in medical scanners, is surrounded by these invisible field lines, reaching out into space like the arms of an octopus, grasping and influencing everything around them. To understand magnetic fields, we need to start with something wonderfully simple yet profoundly mysterious. The fact that moving electric charges create magnetism, and changing magnetic fields create electricity. This elegant dance between electricity and magnetism, discovered in the 19th century by scientists like Michael Faraday and James Clerk Maxwell, reveals that these two forces are really two faces of the same coin: electromagnetism. It's a relationship so fundamental that it literally holds our technological world together, powering everything from the device you might be listening on to the vast generators that bring electricity to your home. But let's step back from human technology for a moment and consider where magnetic fields come from in the natural world. Deep beneath your feet, about 3,000 kilometers down, the Earth harbors a churning ocean of liquid iron and nickel. This isn't a calm, still lake, but a roiling, convecting mass heated by the decay of radioactive elements and the leftover warmth from our planet's violent birth 4.5 billion years ago. As this molten metal flows and swirls, Driven by the Earth's rotation and convection currents, it creates electric currents on a planetary scale. And those electric currents, following the laws discovered by those 19th century scientists, generate magnetic fields. This process, known as the geodynamo, has been running for most of Earth's history, creating the magnetic field that surrounds our entire planet like an invisible cocoon. If you could somehow see magnetic field lines, you'd observe them streaming out of the Earth near the South Pole, arcing gracefully through space, and diving back into the planet near the North Pole. The field extends far beyond the atmosphere, forming a protective boundary called the magnetosphere that deflects most of the charged particles streaming from the sunday. This protective embrace isn't just a curiosity, it's one of the reasons life as we know it exists. Without Earth's magnetic field, the solar wind, that constant stream of charged particles flowing from our star, would gradually strip away our atmosphere, leaving us as barren as Mars, which lost most of its protective magnetic field billions of years ago. The thin air you're breathing right now, the water in the oceans, the entire biosphere that cradles all life, all of it, owes its existence, at least in part, to the invisible magnetic shield generated by molten metal flowing in the darkness far below. But Earth's magnetic field isn't perfectly stable or uniform. It wanders, weakens, strengthens, and occasionally, on timescales of hundreds of thousands of years, it flips completely, with magnetic north becoming south and vice versa. These reversals are recorded in the rocks of the ocean floor, in ancient lava flows, and in the magnetic minerals that settled in lake beds millions of years ago. They tell the story of a dynamic, ever-changing magnetic field that has been our planet's invisible guardian throughout the ages. Yet Earth's magnetic field is just one note in a vast cosmic symphony. Every planet with a liquid, conducting core or significant electric currents, creates its own magnetic field. Jupiter, that giant among planets, possesses a magnetic field nearly 20,000 times stronger than Earth's, generated not just by metallic hydrogen in its core, but by the rapid rotation of its entire bulk. Its magnetic field is so powerful that it traps charged particles in radiation belts that would be lethal to any spacecraft or astronaut venturing too close. Saturn, with its ethereal rings, also harbours a strong magnetic field, one that helps shape and sculpt those very rings by influencing the charged particles of dust and ice that comprise them. Even tiny Mercury, despite its small size, maintains a weak but detectable magnetic field, while Venus and Mars, lacking the right conditions in their cores, have lost most of their magnetic protection to space. But planetary magnetic fields are just the beginning. As we venture beyond our solar system, we discover that magnetic fields permeate the cosmos at every scale imaginable. Our Sun, that familiar golden disk in the sky, is actually a seething ball of plasma-ionized gas so hot that electrons have been stripped from their atoms, creating a sea of charged particles. As this plasma churns and rotates, it generates magnetic fields of staggering complexity and power. The Sun's magnetic field isn't a simple, neat dipole like Earth's. Instead, it's a tangled, twisted maze of field lines that loop and spiral through the solar atmosphere. These field lines become visible during solar eclipses as the corona, that ghostly glow surrounding the Sun when the Moon blocks its bright disk. The corona's delicate streamers and arcs are actually the paths of magnetic field lines, traced out by the hot plasma that follows them like iron filings following the field of a bar magnet. Sometimes, these solar magnetic field lines become so twisted and stressed that they snap, releasing enormous amounts of energy in events called solar flares. These explosions can hurl billions of tons of charged particles into space, at speeds approaching a significant fraction of the speed of light. When these particles encounter Earth's magnetic field, they can create geomagnetic storms that disrupt satellites, interfere with radio communications, and paint the polar skies with the ethereal curtains of the aurora. The aurora, those shimmering green, blue, and red curtains, that dance across the night sky near Earth's poles are perhaps the most beautiful manifestation of magnetic fields that most of us will ever witness. They occur when charged particles from the Sun, guided by Earth's magnetic field lines, plunge into our upper atmosphere near the magnetic poles. As these particles collide with oxygen and nitrogen atoms in the thin air, they cause them to glow, creating those otherworldly displays that have inspired myths and legends for millennia. But even our Sun's magnetic field is dwarfed by the fields surrounding other stars. Some stars, called magnetars, possess magnetic fields trillions of times stronger than Earth's, so powerful that they could erase the magnetic strip on a credit card from halfway across the solar system. These exotic objects, thought to be ultra-dense neutron stars with magnetic fields approaching the theoretical maximum allowed by physics, can release more energy in a single magnetic field reconfiguration than our Sun produces in centuries. As we zoom out further, we discover that magnetic fields extend their influence far beyond individual stars and planets. They thread through the space between stars, creating vast networks that span entire galaxies. Our own Milky Way is pervaded by magnetic fields that align roughly with the spiral arms, helping to channel the flow of cosmic rays, high-energy particles that zip through space at nearly the speed of light. These galactic magnetic fields play crucial roles in star formation. As clouds of gas and dust collapse under their own gravity to form new stars, magnetic fields can either help or hinder the process, threading through the collapsing material and influencing how it falls together. In some cases, magnetic fields provide support against gravity, preventing cloud collapse. In others, they channel material along field lines, creating the conditions necessary for stars to be born. The interplay between gravity and magnetism in star-forming regions creates some of the most beautiful and complex structures in the universe. Stellar nurseries like the Eagle Nebula or the Orion Nebula reveal intricate patterns of gas and dust that have been sculpted by magnetic fields over millions of years. These cosmic sculptures, visible through our most powerful telescopes, are the artistic expressions of invisible magnetic forces at work on scales that dwarf human imagination. But perhaps most remarkably of all, magnetic fields appear to extend their influence to the very largest scales in the universe. Galaxy clusters, vast collections of hundreds or thousands of galaxies bound together by gravity, are also threaded with magnetic fields. These fields, though incredibly weak by terrestrial standards, span millions of light-years and may play important roles in the evolution and behavior of these cosmic megastructures. Even more intriguing is the possibility that magnetic fields exist in the vast, seemingly empty spaces between galaxy clusters, the cosmic voids that make up most of the volume of the observable universe. These primordial magnetic fields, if they exist, might be remnants from the very early universe, fossil traces of processes that occurred when the cosmos was young, hot, and far more densely packed with matter and energy than it is today. The study of these cosmic magnetic fields is pushing the boundaries of our technology and understanding. Radio telescopes can detect the faint signals that reveal magnetic fields in distant galaxies. Specialized instruments on spacecraft measure the magnetic fields of planets and the space between them. Computer simulations attempt to model how magnetic fields evolve over cosmic time, from the birth of the first stars to the far future, when the universe will be cold, dark, and empty. What emerges from all this research is a picture of a universe that is far from the empty, cold vacuum it might appear to be. Instead, it's a cosmos alive with invisible structure, threaded through with magnetic field lines that connect the smallest particles to the largest structures, creating a hidden framework upon which the visible universe is built. These fields channel energy, guide the formation of stars and galaxies, and even influence the chemistry that makes life possible. So as you lie there, surrounded by the familiar objects of your room, remember that you're also immersed in this vast, invisible ocean of magnetism, The magnetic field lines threading through your space right now connect you to the molten iron churning in Earth's core, to the plasma fires of the Sun, to the spiral arms of the Milky Way, and ultimately to the cosmic web of magnetic fields that spans the observable universe. It's a humbling and oddly comforting thought that we're not isolated specks in an empty cosmos, but integral parts of an interconnected electromagnetic tapestry that links all things, seen and unseen. From the quantum scale to the cosmic horizon, the invisible architects of the universe are all around us, quietly shaping the cosmos with their elegant, mathematical precision. Now let's drift a little closer to home and explore how these invisible magnetic architects shape the very air we breathe and the ground beneath our feet. You might think of a magnet as something simple, perhaps that horseshoe-shaped piece of metal you played with as a child, watching it mysteriously attract paper clips and repel other magnets. But the magnetism we encounter in everyday life is just the gentlest whisper of forces that can literally move mountains, stir oceans, and sculpt continents over geological time. Every rock, every grain of sand, every crystal in the Earth's crust contains tiny magnetic minerals that record the history of our planet's magnetic field, like a vast stone library. When volcanic lava cools and solidifies, the magnetic minerals within it align themselves with Earth's magnetic field at that moment, freezing that orientation in place for millions of years. This process, called thermal magnetization, has given us one of the most beautiful and unexpected gifts in all of science, the ability to read the magnetic memories of stones. By studying these fossilized magnetic orientations in rocks of different ages, scientists have discovered something remarkable. The Earth's magnetic field has flipped its polarity hundreds of times throughout history. What we call magnetic north today was magnetic south a million years ago, and it will likely flip again sometime in the future. These reversals don't happen overnight, they unfold over thousands of years, during which the magnetic field weakens, wobbles, and eventually settles into its new orientation, like a spinning top, finally finding its balance. During these transition periods, our planet's magnetic shield becomes patchy and weak, allowing more cosmic radiation to reach the surface. Some scientists wonder if these magnetic reversals might have influenced the course of evolution, creating periods of increased mutation rates that led to bursts of biological innovation. It's a poetic thought that the invisible magnetic field surrounding our planet might have helped write the story of life itself. But magnetic fields don't just record the past. They actively shape the present in ways both subtle and profound. Consider the humble compass needle, that simple sliver of magnetized metal that has guided human exploration for over 1,000 years. That needle doesn't point to true geographic north instead. It aligns itself with the magnetic field lines flowing from Earth's magnetic North Pole, which currently lies somewhere in the Canadian Arctic, hundreds of miles from the geographic pole. What's particularly fascinating is that magnetic north isn't stationary. It wanders across the Arctic landscape at a pace of about 25 miles per year, following the swirling currents in Earth's liquid iron core far below. This wandering has accelerated in recent decades, forcing cartographers to constantly update their maps and navigation systems. The magnetic North Pole that guided Shackleton across Antarctic ice is not the same magnetic North Pole that guides ships today. This wandering magnetic pole creates a constantly shifting pattern of magnetic declination, the difference between magnetic north and true north that varies depending on where you are on Earth's surface. In some places, a compass needle points east of true north. In others, it points west. There's even a line called the agonic line, where magnetic and true north align perfectly, though this line itself shifts and moves as the magnetic field changes. For migrating animals, these magnetic variations create a three-dimensional map more complex and detailed than any GPS system. Sea turtles, salmon, and countless species of birds navigate using Earth's magnetic field as their primary compass, but they don't just sense magnetic north. They can detect the subtle variations in field strength and inclination that create unique magnetic signatures for different locations on the planet. A loggerhead turtle hatching on a Florida beach carries within its nervous system a magnetic map of the entire Atlantic Ocean. As it swims out into the Gulf Stream, it follows magnetic highways that guide it on a journey lasting years and covering thousands of miles. The turtle can distinguish between magnetic signatures that might differ by less than the width of a pencil line on a traditional map, using this invisible guidance system to navigate with precision that would impress any airline pilot. But magnetism's influence on life goes deeper than navigation. The magnetic minerals found in the cells of many organisms, from bacteria to birds to human beings, suggest that life and magnetism have been intertwined since the earliest days of biology on Earth. Some bacteria contain tiny crystals of magnetite that act like internal compass needles, helping them orient themselves in sediments and water columns. These magnetotactic bacteria were among the first organisms discovered to use Earth's magnetic field for navigation, and they've been doing it for billions of years. Even more intriguing are the magnetic crystals found in human brain tissue. While we don't yet fully understand their purpose, some researchers speculate that these biological magnets might be remnants of an ancient magnetic sense that we've largely lost over the course of evolution. There are tantalizing hints that some people might still possess weak magnetic sensitivity, the ability to sense direction or feel the approach of magnetic storms, though such abilities, if they exist, are far subtler than the magnetic senses of migrating animals. The interaction between biological systems and magnetic fields becomes particularly fascinating when we consider the aurora once more, but this time from the perspective of the life forms that witness it. The Inuit peoples of the Arctic have dozens of words for different types of aurora, each describing subtle variations in color, movement, and intensity. They speak of dancing spirits, celestial pathways, and bridges between worlds, poetic interpretations of the complex electromagnetic phenomena occurring in the upper atmosphere. What they're witnessing is the visible manifestation of Earth's magnetic field lines being disturbed by solar storms. When a particularly strong burst of particles from the Sun encounters our magnetosphere, it can cause the field lines to snap and reconnect in explosive events that release tremendous amounts of energy. This energy cascades down the field lines toward the polar regions, where it excites atmospheric gases and creates those ethereal curtains of light. But the aurora isn't just beautiful, it's also a warning sign. The same magnetic disturbances that create spectacular light shows can also wreak havoc on our technology. Satellites can be damaged by the increased radiation, GPS systems can become unreliable, and power grids can experience surges that lead to blackouts. The Great Geomagnetic Storm of 1859, known as the Carrington Event, was so powerful that telegraph lines sparked and caught fire, and aurora were visible as far south as the Caribbean. In our modern world, with its intricate web of electronic systems, a Carrington-level event would be catastrophic. Imagine a world where satellites go dark, the internet fails, power grids collapse, and GPS navigation becomes unreliable, all because of invisible magnetic fields being disturbed by particles from the sunday. It's a sobering reminder that we live at the mercy of forces far beyond our control, forces that operate on scales both vast and intimate. As we venture beyond Earth's protective magnetic embrace, we discover that other worlds in our solar system tell their own magnetic stories. Mars, that rusty red neighbor that has captured human imagination for centuries, once possessed a global magnetic field much like Earth's, but sometime in its distant past, perhaps when its core cooled and solidified, Mars lost its magnetic shield. Without this protection, the solar wind gradually stripped away most of its atmosphere, transforming what might once have been a warm, wet world into the cold desert we see today. The magnetic history of Mars is written in its rocks, just as Earth's history is preserved in ours. Orbiting spacecraft have mapped the remnant magnetic fields embedded in the Martian crust, revealing ghostly traces of the planet's magnetic past. These fossil magnetic fields create a patchwork pattern across the Martian surface, strongest in the ancient southern highlands, where the oldest rocks preserve memories of the planet's long-lost magnetosphere. Venus presents a different mystery altogether. Despite being nearly Earth's twin in size and composition, Venus has virtually no magnetic field at all. Its core should be hot enough to maintain the kind of convection that drives Earth's geodynamo, yet something has prevented Venus from generating a substantial magnetic field. Some scientists speculate that Venus's incredibly slow rotation, it takes 243 Earth days to complete one spin, might be the culprit, as the rotation rate might be too slow to organize the convection currents needed for magnetic field generation. Jupiter, however, more than makes up for the magnetic deficiencies of Mars and Venus. The king of planets possesses a magnetic field so powerful and complex that it defies easy description. Generated not just by metallic hydrogen in its core, but also by the rapid rotation of its massive bulk, Jupiter's magnetosphere extends far beyond the orbit of its largest moons, and would appear larger than the full moon if we could see it from Earth. This Jovian magnetic field creates radiation environments around the planet that would be instantly lethal to unprotected humans. The charged particles trapped in Jupiter's magnetic field create radiation belts that make Earth's Van Allen belts look positively benign by comparison. When spacecraft venture into this electromagnetic maelstrom, they must be specially shielded to survive the onslaught of high-energy particles guided by Jupiter's magnetic field lines. But perhaps the most remarkable aspect of Jupiter's magnetic field is how it interacts with its moons. Io, that sulfur-painted volcanic world, generates enormous electric currents as it moves through Jupiter's magnetic field. These currents, flowing between Io and Jupiter's upper atmosphere, carry millions of amperes of electrical power, enough to supply all of human civilization many times over. The interaction creates radio emissions so powerful they can be detected by radio telescopes on Earth, turning the Jupiter system into a natural radio beacon broadcasting across the solar system. Europa, Jupiter's ice-covered moon that may harbour an ocean beneath its frozen crust, also interacts with the giant planet's magnetic field in revealing ways. As Europa orbits through Jupiter's magnetosphere, the interaction between the moon's suspected subsurface ocean and the magnetic field creates a secondary magnetic signature that spacecraft can detect. This magnetic interaction has provided some of our strongest evidence that Europa indeed harbours a liquid ocean beneath its icy shell, an ocean that might, just might, contain life. Saturn's magnetic field, while weaker than Jupiter's, creates its own wonders. The planet's magnificent ring system is sculpted and maintained partly by magnetic forces. Charged particles in Saturn's magnetosphere interact with ring material, creating spokes, dark radial features that rotate with the magnetic field rather than following the orbital motion of the ring particles themselves. These spokes, first discovered by the Voyager spacecraft, remain somewhat mysterious, but they clearly demonstrate the intimate connection between Saturn's magnetic field and its most distinctive feature. Even tiny, distant Pluto, no longer classified as a planet but no less fascinating for that demotion, may possess interactions with the solar wind that create a kind of mini magnetosphere. As the solar wind encounters Pluto's thin atmosphere, it may create a magnetic wake downstream from the dwarf planet, much like the wake created by a rock in a flowing stream. These planetary magnetic fields, diverse as they are, all pale in comparison to the magnetic phenomena we encounter when we look beyond our solar system to the realm of other stars. Some stars generate magnetic fields thousands of times stronger than the Sun's, creating stellar magnetospheres that can trap and accelerate particles to incredible energies. When these supercharged particles crash into the star's atmosphere, they create auroral displays that dwarf anything seen on Earth's stellar light shows that can be detected across interstellar distances. The most extreme magnetic fields in the universe belong to those exotic objects called magnetars neutron stars, with magnetic fields so intense they challenge our understanding of physics itself. A magnetar's magnetic field is strong enough to strip the electrons from atoms at a distance of 1,000 miles, turning the space around these objects into a realm where matter behaves in ways that seem almost supernatural. If a magnetar existed at the distance of the moon, its magnetic field would erase every credit card, hard drive, and magnetic storage device on Earth. Yet even these extreme stellar magnetic fields are just individual notes in the vast symphony of cosmic magnetism that permeates our galaxy and beyond. The Milky Way itself is threaded with magnetic field lines that stretch across thousands of light years, creating invisible highways along which cosmic rays travel at nearly the speed of light. These galactic magnetic fields influence everything from the formation of new stars to the spiral structure of our galaxy's arms. As we lie here in the quiet of the night, it's worth pausing to appreciate the magnificent complexity of the invisible magnetic architecture that surrounds us. From the tiny magnetic crystals in bacteria to the vast field lines that thread through galaxy clusters, from the compass needle pointing north to the aurora dancing in polar skies, we exist within a cosmic web of magnetism that connects all scales of existence in ways we're only beginning to understand. But magnetic fields aren't merely cosmic curiosities or abstract scientific concepts, they're active participants in the grand theatre of stellar birth and death, sculpting the very cradles where new stars come into being, and orchestrating the spectacular final acts when massive stars reach the end of their luminous lives. If you could peer into the vast molecular clouds that drift between the stars, those dark, cold nurseries where future suns slowly coalesce from gas and dust, you'd discover magnetic fields threading through them like invisible scaffolding, supporting some regions against gravitational collapse while channeling material toward others. These star-forming regions reveal magnetism at its most architectural. The Eagle Nebula, with its famous pillars of creation, shows us towering columns of gas and dust that have been carved and shaped by the interplay between stellar winds, radiation pressure, and magnetic fields. The field lines act like invisible buttresses, providing structural support that allows these delicate spires to maintain their form for millions of years. Without magnetic fields, these cosmic sculptures would collapse under their own weight in mere thousands of years, denying us some of the most beautiful sights in the universe. When a massive star finally exhausts its nuclear fuel and begins its death throes, magnetic fields play an even more dramatic role. During the final seconds of a supernova explosion, the collapsing stellar core generates magnetic fields of unimaginable strength. These fields help drive the shock wave that blasts the star's outer layers into space, seeding the surrounding interstellar medium with heavy elements forged in the stellar furnace. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were scattered across space by explosions powered, in part, by magnetic fields. Some of these stellar remnants become neutron stars, objects so dense that a teaspoon of their material would weigh as much as Mount Everest. As the original star's magnetic field gets compressed along with its matter, the field strength increases by factors of trillions, creating those magnetars we mentioned earlier. But even ordinary neutron stars possess magnetic fields millions of times stronger than Earth's, concentrated into objects just 12 miles across, yet containing more mass than our Sunday. These neutron stars become cosmic lighthouses, their magnetic fields channeling charged particles into narrow beams that sweep across space as the star rotates. When these beams happen to point toward Earth, we detect them as pulsars rapidly repeating radio signals, so precisely timed they rival atomic clocks in their accuracy. The first pulsar discovery in 1967 was so unexpected that astronomers briefly wondered if they might be detecting signals from alien civilizations, calling the source LGM, 1 for Little Green Men. The truth that these signals came from the magnetic fields of collapsed stars proved even more extraordinary than the fiction. The magnetic fields of pulsars don't just create radio beams, they can also accelerate particles to such high energies that they produce gamma rays, the most energetic form of electromagnetic radiation in the universe. The Crab pulsar, remnant of a supernova witnessed by Chinese astronomers in 1054 CE, spins 30 times per second and emits pulses of radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. Its magnetic field, spinning at this incredible rate, acts like a cosmic dynamo, generating electric fields strong enough to strip electrons from atoms and accelerate them to nearly the speed of light. But perhaps the most mind-bending aspect of neutron star magnetic fields is how they warp space-time itself. Einstein's general relativity tells us that energy and matter curve the fabric of space-time, and magnetic fields represent a form of energy. The magnetic fields around magnetars are so intense that they actually create measurable distortions in space-time, a phenomenon so extreme that it exists nowhere else in the known universe, except perhaps in the first moments after the Big Bang. These stellar magnetic phenomena might seem distant and irrelevant to our quiet terrestrial existence, but they connect to Earth in subtle yet profound ways. The cosmic rays that constantly shower our planet high-energy particles from deep space are guided and deflected by magnetic fields throughout their journey from distant supernovae to our atmosphere. Some of these particles began their voyage millions of years ago, bouncing off magnetic field lines in interstellar space, spiraling around galactic magnetic highways, and eventually finding their way to Earth where they interact with our own magnetic field and atmosphere. When these cosmic ray particles collide with molecules in our atmosphere, they create cascades of secondary particles that rain down on us constantly. Right now, as you listen to these words, dozens of these cosmic ray particles are passing through your body, every second silent messengers from stellar explosions that occurred when the universe was young. Most pass through without interaction, but occasionally one will strike a DNA molecule or trigger a detector in a physics laboratory, connecting you directly to the magnetic architecture of distant galaxies. The interstellar medium itself, that thin soup of gas and dust that fills the space between stars, is thoroughly permeated by magnetic fields. These fields, though incredibly weak by terrestrial standards, extend across such vast distances that they contain enormous amounts of energy and play crucial roles in galactic dynamics. They help trigger the collapse of molecular clouds into new stars, channel the flow of cosmic rays, and even influence the spiral structure of galaxies like our own Milky Way. Recent observations have revealed that these galactic magnetic fields follow the spiral arms of our galaxy, creating vast magnetic highways that stretch across thousands of light years. These field lines may help maintain the spiral structure itself, providing additional forces that keep the galaxy's arms from winding up too tightly as the galaxy rotates. Without magnetic fields, our beautiful spiral galaxy might look quite different, perhaps more chaotic, with less defined structure and different patterns of star formation. The magnetic field of our galaxy also acts as a partial shield against cosmic rays from other galaxies. While it can't stop these high-energy particles entirely, it can deflect many of them, reducing the cosmic ray flux that reaches Earth. This galactic magnetic shielding may have played a role in making our solar system a more hospitable place for the development of complex life. Too many cosmic rays can damage biological molecules and disrupt atmospheric chemistry, so the magnetic protection provided by our galaxy may be yet another factor in the long chain of cosmic circumstances that made Earth suitable for life. As we zoom out to even larger scales, we discover that magnetic fields extend their influence to galaxy clusters, vast collections of hundreds or thousands of galaxies bound together by gravity. These clusters, the largest gravitationally bound structures in the universe, are filled with hot, ionized gas that glows in X-ray wavelengths. Threading through this intergalactic medium are magnetic fields that, while incredibly weak, span millions of light years and may contain as much energy as all the starlight from all the galaxies in the cluster combined. These cluster magnetic fields reveal themselves through their effects on radio waves from distant galaxies. As radio waves travel through the magnetized plasma of galaxy clusters, they become polarized. Their oscillations align with the magnetic field direction. By studying this polarization, astronomers can map the invisible magnetic architecture of these cosmic megastructures, revealing field patterns that often follow the distribution of dark matter, that mysterious substance that makes up most of the matter in the universe. The connection between magnetic fields and dark matter is particularly intriguing because it suggests that even the most exotic components of our universe participate in the electromagnetic drama that shapes cosmic structure. While dark matter itself doesn't carry electric charge and therefore can't directly generate magnetic fields, its gravitational influence on ordinary matter helps determine where gas flows and how it moves, which in turn affects how magnetic fields evolve and strengthen over cosmic time. Some of the most spectacular manifestations of cosmic magnetic fields occur when galaxies collide. During these titanic encounters, which unfold over hundreds of millions of years, the magnetic fields of the merging galaxies can be stretched, twisted, and amplified to extraordinary strengths. The resulting magnetic turbulence can trigger intense bursts of star formation, as gas clouds are compressed by magnetic pressure waves, creating some of the most luminous and active galaxies in the universe. The antennae galaxies, a pair of spiral galaxies currently in the process of merging about 60 million light-years from Earth, show clear evidence of magnetic field amplification during their cosmic collision. Radio observations reveal magnetic field strengths in the interaction region that are 10 times stronger than typical galactic values, demonstrating how gravitational encounters can dramatically reshape the invisible magnetic architecture of entire galaxies. But perhaps the most mysterious aspect of cosmic magnetism lies in the possibility that magnetic fields might exist even in the vast voids between galaxy clusters, those seemingly empty regions that make up most of the volume of the possibility that magnetic fields. Observable universe. If such primordial magnetic fields exist, they would be incredibly weak, perhaps a trillion times weaker than Earth's field, yet they would represent some of the oldest structures in the cosmos, possibly dating back to the first moments after the Big Bang. The origin of these hypothetical primordial fields remains one of the great unsolved puzzles in cosmology. How could magnetic fields arise in the early universe when matter was still smooth and evenly distributed? Various theories propose exotic mechanisms involving phase transitions in the fundamental forces, quantum fluctuations inflated to cosmic scales, or the motion of charged particles in the primordial plasma that filled the universe before the first atoms formed. If primordial magnetic fields do exist, they might have played important roles in the formation of the first stars and galaxies. Even incredibly weak magnetic fields can influence how gas moves and collapses under gravity, potentially seeding the formation of the cosmic web, that vast network of filaments and voids that gives large-scale structure to our universe. In this scenario, the patterns of galaxies and dark matter we observe today might be, in part, the legacy of magnetic fields that were imprinted on the cosmos when it was less than a second old. The study of cosmic magnetic fields pushes our technology to its limits and beyond. Radio telescopes must detect incredibly faint signals that have traveled for billions of years across space. Space-based observatories use sophisticated instruments to measure magnetic fields in our solar system and beyond. Computer simulations require supercomputers to model the complex interactions between gravity, gas dynamics, and magnetism on cosmic scales. One of the most ambitious projects in this field is the Square Kilometre Array, a radio telescope network that will eventually span continents and possess unprecedented sensitivity to cosmic magnetic phenomena. When complete, this instrument will be able to detect and map magnetic fields in galaxies so distant that their light left them when the universe was only a fraction of its current age, allowing us to study how cosmic magnetism has evolved over most of cosmic history. These observations are crucial because they help us understand not just how magnetic fields behave, but how they participate in the broader story of cosmic evolution. From the formation of the first stars to the assembly of galaxy clusters, from the recycling of stellar material to the protection of planetary atmospheres, magnetic fields appear to be essential players in nearly every important process that has shaped our universe. What emerges from all this research is a picture of a cosmos that is far more interconnected and dynamic than we might have imagined. The magnetic field lines that thread through space don't just sit there passively, they channel energy, guide the flow of matter, and create invisible bridges that connect objects separated by vast distances. A solar flare on the surface of our Sun can trigger auroras on Earth and influence the magnetic environment around Jupiter. A supernova explosion in a distant part of our galaxy can send cosmic rays spiraling along magnetic highways until they reach our solar system millions of years later. This interconnectedness extends down to the most intimate scales of our existence. The atoms in your body were forged in stellar furnaces and scattered by supernova explosions, guided by magnetic fields. The planet you live on is protected by a magnetic shield generated by molten metal flowing thousands of miles beneath your feet. The compass that helped early explorers navigate unknown seas responds to magnetic field lines that connect to currents flowing in the Earth's core. Even the aurora that occasionally dance in polar skies above are manifestations of the same magnetic forces that operate in the hearts of distant galaxies. So as you rest there in the gentle darkness, consider that you are immersed in layers upon layers of magnetic influence. The local magnetic field of Earth surrounds you like an invisible cocoon. The Sun's magnetic field, carried by the solar wind, washes over our entire solar system. The magnetic field of our galaxy threads through the space around us, connecting us to the spiral arms and the galactic center. And perhaps, reaching back to the very beginning of time, primordial magnetic fields whisper to us across the cosmic ages, carrying messages from the universe's earliest moments. These invisible architects work on timescales that dwarf human experience, yet their influence touches every moment of our lives. They operate according to elegant mathematical laws, yet their manifestations can surprise us with their beauty and complexity. They are utterly alien to our everyday experience, yet they are as fundamental to the universe's structure as gravity or the nuclear forces that power the stars. In the grand symphony of cosmic forces, magnetic fields provide both the subtle harmonies that give structure to the composition and the dramatic crescendos that mark the universe's most spectacular events. They are the invisible conductors, guiding the cosmic orchestra through its eternal performance, ensuring that every particle, every planet, every star plays its part in the magnificent, ongoing creation that we call the universe. And as we drift deeper into this magnetic cosmos, let's explore one of the most intimate ways these invisible fields touch our daily lives through the remarkable technology that surrounds us. Much of it so commonplace that we barely notice the magnetic marvels powering our modern world. The device you might be listening to this on right now, whether it's a smartphone resting on your bedside table or headphones gently covering your ears, is a symphony of magnetic engineering that would have seemed like pure magic to scientists just a century ago. Consider the tiny speaker that's delivering these words to you. Inside its modest casing lies a precisely engineered magnetic system, a permanent magnet, creating a steady magnetic field, and an electromagnet formed by a coil of wire wrapped around a movable cone. As electrical signals from your device flow through this coil, they create a changing magnetic field that interacts with the permanent magnet, causing the cone to vibrate back and forth. These vibrations push air molecules, creating the sound waves that your ears interpret as spoken words about the invisible architecture of the universe. It's magnetism made audible, electromagnetic forces transformed into human speech. If you're listening through wireless headphones, the magnetic dance becomes even more intricate. The audio signal travels through the air as electromagnetic waves, radio frequencies that pulse through space at the speed of light. Your headphones capture these invisible transmissions using antennas no bigger than your fingernail, convert them back into electrical signals, and then use those tiny magnetic speakers to recreate the original sound. All of this happens in real time, with delays measured in thousandths of a second, orchestrated by magnetic fields and electromagnetic radiation working in perfect harmony. The hard drive spinning quietly in your computer, if it still uses traditional magnetic storage, is perhaps one of the most elegant applications of magnetism in everyday technology. Imagine billions of microscopic magnetic domains, each smaller than a virus, arranged in precise patterns across a spinning disk. These tiny magnets can be flipped between two orientations, pointing up or down to represent the ones and zeros of digital information. A magnetic head, floating just nanometers above the disk's surface on a cushion of air, reads and writes these magnetic patterns at speeds that would make your head spin literally, since the disk rotates thousands of times per minute. Every photo you've taken, every song you've downloaded, every video you've watched exists as patterns of magnetized particles on that spinning disk. Your memories, your digital life, preserved in the orientation of countless microscopic magnets that remember their state even when the power is turned off. It's a form of technological memory that mirrors, in some ways, the magnetic memory preserved in rocks throughout geological time. The electric motor that powers your refrigerator's compressor, the fan that cools your laptop, the vibration motor that buzzes when you receive a text message, all rely on the fundamental relationship between magnetism and motion discovered by Michael Faraday nearly 2 centuries ago. When electric current flows through a coil of wire placed in a magnetic field, the coil experiences a force that causes it to move. This principle, simple enough to demonstrate with a battery, some wire, and a magnet, powers everything from the smallest smartphone vibrator to the massive motors that drive subway trains. But the magnetic influence on our technology goes far beyond the obvious applications. The very electricity flowing through the wires in your walls was generated by massive electromagnets in power plants, where steam or water or wind spins enormous coils of wire through powerful magnetic fields. Every time you flip a light switch, you're completing a circuit that traces back to magnetic induction occurring in generators that might be hundreds of miles away. The photons illuminating your reading light began their existence as mechanical motion converted to electrical energy through magnetic fields, then traveled through copper wires guided by magnetic principles, and finally emerged as light when electricity flowed through the tungsten filament or LED array in your bulb. Even the GPS system that helps you navigate unknown streets relies on magnetic fields in ways both obvious and subtle. The satellites orbiting overhead use magnetic torquers, electromagnets that interact with Earth's magnetic field to orient themselves in space without using fuel. These magnetic attitude control systems allow the satellites to point their antennas toward Earth and their solar panels toward the Sun with precision measured in fractions of degrees. Meanwhile, the atomic clocks that provide the precise timing essential for GPS operation are shielded from magnetic fields that could disrupt their quantum mechanical precision. Credit cards and key fobs carry their information in magnetic stripes and chips that store data as patterns of magnetization. The magnetic strip on your credit card contains iron-based particles suspended in a resin, arranged in tracks that encode your account information in magnetic patterns. When you swipe the card, a magnetic reader detects these patterns and translates them back into the digital information needed to process your transaction. It's a technology so reliable and ubiquitous that we rarely think about the magnetic choreography occurring every time we make a purchase. Medical imaging reveals perhaps the most sophisticated application of magnetism in service of human well-being. Magnetic resonance imaging machines create magnetic fields tens of thousands of times stronger than Earth's, strong enough to align the nuclear spins of hydrogen atoms in your body. By then pulsing radio waves through your tissues and listening to the magnetic echoes that return, these machines can create detailed images of your internal organs without using any ionizing radiation. The soft tissues that would be invisible to X-rays reveal their secrets to magnetic fields, allowing doctors to peer inside the living body with unprecedented clarity and safety. The magnetic field inside an MRI machine is so powerful that it can turn any ferromagnetic object into a dangerous projectile. Oxygen tanks, wheelchairs, even hairpins can become missiles if they enter the magnetic field unexpectedly. Yet this same field, when properly controlled and combined with radio waves and sophisticated computer processing, becomes a window into the human body that has revolutionized medical diagnosis and treatment. But magnetism's role in medicine extends beyond imaging. Targeted drug delivery systems use magnetic nanoparticles that can be guided through the bloodstream using external magnetic fields, allowing medications to be directed precisely to tumors or other diseased tissues. Magnetic hypothermia treatments heat cancer cells by subjecting magnetic particles within them to alternating magnetic fields. Even depression and other neurological conditions can sometimes be treated using transcranial magnetic stimulation, where powerful magnetic pulses applied to specific areas of the brain can alter neural activity in therapeutic ways. The transportation systems that move us through our daily lives are increasingly magnetic in nature. The electric motors in hybrid and electric vehicles use powerful permanent magnets made from rare earth elements to achieve efficiencies that would be impossible with conventional motors. Regenerative braking systems use these same motors in reverse, converting the car's kinetic energy back into electricity through magnetic induction, storing it in batteries for later use. Magnetic levitation trains, though still rare, represent the ultimate marriage of transportation and magnetism. These vehicles float above their tracks on magnetic fields, eliminating friction and allowing speeds that rival aircraft. The forces that lift these trains are the same electromagnetic forces we've been exploring throughout our journey, scaled up and precisely controlled to support tons of passengers and cargo with nothing but invisible magnetic fields. Even the humble bicycle light that keeps you visible on evening rides likely uses a dynamo, a small generator that converts the rotation of your wheel into electricity through magnetic induction. As magnets spin past coils of wire inside the dynamo, they generate the current that powers your lights, creating a direct connection between your pedaling motion and the photons that help keep you safe on the road. The computers processing these words, whether in your device or in distant servers, rely on magnetic fields at the most fundamental level of their operation. The quantum mechanical properties of electrons, their spin and magnetic moments, are manipulated in transistors to create the switching behavior that underlies all digital computation. Even the newest quantum computers, which promise to revolutionize computing by harnessing quantum mechanical effects directly, often use magnetic fields to control and read the quantum states of their qubits. Wireless charging pads use magnetic fields to transfer power without physical connections, employing the same principles of electromagnetic induction that power electric generators, but in miniature. A coil in the charging pad creates an oscillating magnetic field that induces currents in a corresponding coil inside your phone or other device. Energy flows through space itself, carried by magnetic field lines that bridge the gap between charger and device. The very screens displaying information to us throughout our days often rely on magnetic deflection systems. While modern flat panel displays use different technologies, the cathode ray tube televisions and computer monitors of previous generations steered electron beams using precisely controlled magnetic fields. These electrons, guided by magnetism, painted images on phosphorescent screens one line at a time, creating the moving pictures that entertained and informed generations before the digital age. Even something as simple as a doorbell involves electromagnetic principles. When you press the button, electric current flows through an electromagnet that creates a magnetic field strong enough to attract a metal striker, which hits the bell and creates the familiar chime. The magnetic field appears and disappears in an instant, but that brief pulse of magnetism announces your presence with a sound that has welcomed visitors to homes for more than a century. The magnetic influence extends to the realm of data storage in ways that continue to evolve. While traditional hard drives store information in magnetic patterns, newer solid-state drives use quantum mechanical effects in semiconductor materials. Yet even these devices often rely on magnetic sensors to detect their orientation and adjust their behavior accordingly. The accelerometers in your smartphone that know when you've rotated the device often use magnetic fields to sense tiny movements of microscopic proof masses. Industrial manufacturing increasingly depends on magnetic technologies. Magnetic separation systems sort materials by their magnetic properties, extracting iron from ore, removing metal contaminants from food products, and separating different types of recycled materials. Electromagnetic brakes and clutches control machinery with precision impossible to achieve through purely mechanical means. Magnetic bearings support rotating equipment without physical contact, eliminating wear and allowing machines to operate at speeds and in environments that would destroy conventional bearings. The speakers in your car, the motors in your household appliances, the transformers that step down high-voltage electricity to safely power your home, all are manifestations of the electromagnetic principles we've been exploring. These technologies have become so integrated into modern life that we rarely pause to consider the invisible magnetic forces that make them possible. Yet perhaps the most profound way that magnetism touches our daily lives is through its role in the fundamental forces that hold matter itself together. The electromagnetic force that governs magnetic phenomena is also responsible for the chemical bonds that hold molecules together, the forces that give solidity to the objects around you, and the interactions between light and matter that allow you to see. Every breath you take, every bite of food you digest, every thought that passes through your brain involves electromagnetic interactions at the atomic and molecular level. The very sensation of touch that you feel when you run your fingers across a surface is electromagnetic in nature. The atoms in your skin never actually make contact with the atoms in the object you're touching. Instead, the electron clouds around those atoms repel each other through electromagnetic forces, creating the sensation of solidity and texture. You're feeling the effects of magnetic and electric fields operating at distances smaller than the wavelength of visible light. Color itself is an electromagnetic phenomenon. The photons entering your eyes are packets of electromagnetic energy, and their magnetic and electric field components oscillate at frequencies that your brain interprets as different hues. The red glow of sunset, the blue of the sky, the green of leaves, all are manifestations of electromagnetic radiation interacting with matter through processes governed by the same fundamental forces that create the magnetic fields threading through galaxies. So as you settle deeper into rest, surrounded by the quiet hum of magnetic technology, remember that you're not just observing these invisible forces from the outside, you're participating in them. The iron in your blood responds weakly to magnetic fields. The electrical activity in your nervous system creates tiny magnetic fields that can be detected by sensitive instruments. The very atoms that make up your body contain spinning charges that give them magnetic properties. You are, in a very real sense, a magnetic being living in a magnetic universe, connected through invisible field lines to every other magnetic entity in the cosmos. From the smartphone beside your pillow to the spiral galaxy overhead, from the tiny compass needle finding north to the vast magnetic highways that channel cosmic rays across intergalactic space, you're part of an interconnected electromagnetic tapestry that spans from the quantum to the cosmic. The technology surrounding you is just the most visible manifestation of humanity's growing partnership with these invisible forces. We've learned to harness magnetism, to amplify it, to shape it to our purposes. But in doing so, we've also become more deeply embedded in the magnetic architecture of the universe, our artificial magnetic fields, adding their whispers to the cosmic electromagnetic symphony that has been playing since the first moments after the Big Bang. Tonight, as magnetic fields guide electrons through the circuits of your devices, as electromagnetic waves carry signals through the air around you, as the Earth's magnetic field deflects charged particles from space high above your head, you rest at the center of magnetic phenomena operating across every scale of existence. It's a reminder that in this interconnected universe, nothing exists in isolation. Everything is connected through the invisible threads of electromagnetic force that bind the cosmos together in one magnificent, ever-evolving magnetic web. And now, as our exploration of these invisible cosmic architects begins to wind toward its gentle conclusion, let's turn our attention to one of the most intriguing frontiers in magnetic research: the possibility that magnetic fields might hold keys to understanding some of the deepest mysteries of physics itself. These invisible forces that we've traced from the iron core of our planet to the spiral arms of distant galaxies may be pointing the way toward revelations about the fundamental nature of reality that would have seemed like pure fantasy just decades ago. At the bleeding edge of theoretical physics, researchers are discovering that magnetic fields might play crucial roles in phenomena so exotic they challenge our most basic assumptions about space, time, and matter. Consider the enigma of dark matter, that invisible substance that makes up about 27% of the universe, yet reveals itself only through its gravitational effects. While dark matter doesn't interact electromagnetically in the way ordinary matter does, some theoretical models propose that it might possess its own hidden magnetic properties, participating in a shadow electromagnetic sector that remains largely invisible to us. If such dark magnetic fields exist, they could help explain some of the puzzling patterns we observe in galaxy formation and cosmic structure. These invisible magnetic forces might guide the flow of dark matter in ways we're only beginning to imagine, creating a secondary layer of magnetic architecture underlying the visible cosmic web we can observe directly. The very magnetic fields we detect in galaxy clusters might be influenced by dark magnetic fields operating through dimensions we cannot perceive, adding hidden complexity to the cosmic magnetic tapestry. The relationship between magnetism and gravity itself is becoming a frontier of intense research interest. While these forces operate through completely different mechanisms, gravity curves, space-time, while magnetism acts through electromagnetic fields, some theories propose that at extreme energy scales, they might be unified aspects of a more fundamental force. String theory, that ambitious attempt to describe all forces and particles in terms of vibrating multidimensional strings, suggests that magnetic fields and gravitational fields might be different manifestations of the same underlying geometric structures in higher dimensional space. These ideas take on practical significance when we consider black holes, those gravitational monsters where space and time become so distorted that our normal understanding of physics breaks down. Recent observations have revealed that many black holes possess powerful magnetic fields that extend far beyond their event horizons, the point of no return, beyond which nothing can escape. These magnetic fields appear to play crucial roles in how black holes consume matter and energy, channeling infalling material into high-speed jets that can extend for millions of light years. The magnetic fields around black holes create some of the most extreme physical conditions in the known universe. Near the event horizon of a spinning black hole, magnetic field lines can be twisted and amplified to incredible strengths by the dragging of space-time itself. This process, called the magnetorotational instability, can extract energy directly from the black hole's rotation, powering the brilliant jets and accretion disks that make active galactic nuclei among the most luminous objects in the universe. But perhaps most intriguingly, some physicists speculate that magnetic fields might provide windows into parallel universes or extra dimensions predicted by certain theories. If our three-dimensional space is actually a slice of a higher dimensional reality, magnetic field lines might extend into these hidden dimensions in ways we're only beginning to explore. The slight deviations from expected behavior that astronomers sometimes observe in cosmic magnetic fields could be signatures of these extra-dimensional effects, subtle hints that our universe is far stranger and more interconnected than we currently understand. Quantum mechanics adds another layer of mystery to the magnetic story. At the smallest scales, particles don't just have magnetic properties, they exist in quantum superpositions, where they can be simultaneously pointing in multiple magnetic directions until they're measured or observed. This quantum magnetic behavior underlies the operation of quantum computers, which use magnetic fields to manipulate quantum bits that can exist in multiple states simultaneously, potentially allowing them to solve certain problems exponentially faster than classical computers. The quantum nature of magnetism also leads to exotic phases of matter that have no classical analogues. Quantum spin liquids, for instance, are materials where magnetic interactions prevent the formation of conventional magnetic order, creating liquid-like states of quantum entanglement that persist even at absolute zero temperature. These materials might serve as platforms for topological quantum computing, where information is stored not in the properties of individual particles but in the global topological properties of the quantum magnetic state. Even more exotic are the theoretical magnetic monopoles, hypothetical particles that would possess only a north or only a south magnetic pole, unlike ordinary magnets which always have both. While no magnetic monopoles have ever been observed in nature, their existence is predicted by some grand unified theories that attempt to describe all fundamental forces within a single framework. The discovery of magnetic monopoles would revolutionize our understanding of electromagnetism and might provide crucial clues about the unification of all physical forces. The search for these elusive particles has led physicists to study some of the most extreme magnetic environments in the universe. Magnetars, those neutron stars with magnetic fields 1,000,000,000,000 times stronger than Earth's, create conditions where the fabric of space itself becomes magnetically polarized. In such intense fields, even the quantum vacuum, the supposedly empty space between particles, begins to exhibit magnetic properties, potentially creating virtual magnetic monopole pairs that might leave detectable signatures. Magnetic fields also play mysterious roles in the quantum field theories that describe the fundamental forces of nature. The Higgs field, which gives mass to elementary particles, interacts with electromagnetic fields in ways that are still not fully understood. Some theories suggest that strong magnetic fields might alter the properties of the Higgs field itself, potentially leading to phase transitions in the vacuum that could fundamentally change the laws of physics in localized regions of space. These ideas might seem purely academic, but they have profound implications for our understanding of the early universe. During the first moments after the Big Bang, when the cosmos was filled with incredibly hot, dense plasma, magnetic fields might have played crucial roles in shaping the initial conditions that led to the universe we observe today. Some cosmological models propose that primordial magnetic fields, generated through exotic quantum mechanical processes in the first fraction of a second after the Big Bang, could have influenced everything from the formation of the first atoms to the large-scale structure of the cosmic web. The study of magnetic fields is also pushing the boundaries of our technological capabilities in ways that might soon transform human civilization. Fusion energy research relies on incredibly powerful magnetic fields to confine the hot plasma needed for nuclear fusion reactions. These magnetic bottles, created by superconducting electromagnets cooled to near absolute zero, must maintain their grip on plasma heated to temperatures exceeding those in the core of the Sunday. Success in this endeavor would provide humanity with an essentially unlimited source of clean energy, all made possible by our mastery of magnetic field engineering. Room temperature superconductors, if they can be developed, would revolutionize our ability to create and control magnetic fields. Such materials would allow the construction of magnetic levitation systems, energy storage devices, and electric motors with efficiencies approaching 100%. The power grids of the future might use superconducting magnetic energy storage to smooth out fluctuations in renewable energy sources, while magnetic levitation could transform transportation by eliminating friction from trains, ships, and even aircraft. The intersection of biology and magnetism continues to reveal new mysteries and possibilities. Recent research has discovered that many more species than previously thought use magnetic navigation, from sea turtles to fruit flies to humans. The magnetic crystals found in human brain tissue might be evolutionary remnants of ancient magnetic senses, or they might serve functions we haven't yet discovered. Some researchers are exploring whether magnetic fields might be used to enhance human cognitive abilities or treat neurological disorders through precise, non-invasive stimulation of specific brain regions. Perhaps most remarkably, scientists are beginning to explore the possibility that life itself might have magnetic origins. Some theories propose that the first self-replicating molecules emerged in environments with strong magnetic fields, where electromagnetic forces helped organize simple chemicals into more complex structures. If this is true, then the magnetic fields threading through the cosmos might not just be architects of stars and galaxies, they might also be architects of life itself. The magnetic fields of exoplanets, planets orbiting other stars, are becoming a new frontier in the search for habitable worlds. Planets with strong magnetic fields are better protected from stellar radiation, making them more likely to retain atmospheres and maintain stable climates suitable for life. Future space telescopes might be able to detect the magnetic fields of Earth-like exoplanets by observing how they interact with charged particles from their host stars, providing crucial information about their potential habitability. As our instruments become more sensitive and our theoretical understanding deepens, we're discovering that magnetic fields permeate the universe at levels of complexity that would have been unimaginable just a generation ago. The cosmic web of dark matter, long thought to be purely gravitational in nature, might be threaded with magnetic filaments that influence how galaxies form and evolve. The cosmic microwave background radiation, that ancient light from the early universe, might carry subtle magnetic signatures that could reveal new physics operating at the moment of cosmic inflation. Artificial intelligence and machine learning are beginning to contribute to magnetic research in unprecedented ways. These tools can identify patterns in vast datasets of magnetic field measurements, potentially revealing correlations and structures that human scientists might never notice. AI systems trained on the magnetic signatures of different astronomical objects might soon be able to automatically classify and analyze magnetic phenomena across the cosmos, accelerating our understanding of how magnetic fields operate on all scales. The philosophical implications of these discoveries are as profound as their scientific significance. If magnetic fields truly do connect all scales of the universe, from quantum particles to galaxy clusters, then the ancient intuition that everything in the cosmos is interconnected might have a precise scientific basis. The magnetic field lines threading through space might be literal connections linking every atom in your body to the farthest reaches of the observable universe. This interconnectedness suggests that consciousness itself might be embedded in a magnetic cosmos in ways we're only beginning to explore. The electrical activity in your brain creates tiny magnetic fields that extend beyond your skull, connecting you electromagnetically to your environment. Every thought, every memory, every decision you make involves the movement of charged particles that contribute to the magnetic signature of your consciousness. Some researchers speculate that consciousness might be a fundamentally electromagnetic phenomenon arising from the complex patterns of magnetic and electric fields generated by neural activity. If this is true, then your awareness of these words, your ability to contemplate the mysteries of cosmic magnetism, might itself be a manifestation of the same electromagnetic forces that shape galaxies and guide the evolution of the universe. As we stand on the threshold of new discoveries about magnetic fields and their role in the cosmos, we're reminded that science is not just about understanding the world around us. It's about discovering our place within the grand tapestry of existence. The invisible magnetic architects we've explored tonight don't just build cosmic structures. They might also be fundamental to the emergence of complexity, consciousness, and meaning in a universe that continues to surprise us with its elegant interconnectedness. The magnetic fields flowing through space as you rest tonight carry information from the furthest galaxies, energy from ancient stellar explosions, and perhaps even whispers from parallel universes or hidden dimensions. They connect you to the spiral arms of the Milky Way, to the aurora dancing above the polar regions, to the molten iron churning in Earth's core, and to every other magnetic entity in the cosmic web of electromagnetic force. In this vast magnetic universe, you are not a passive observer, but an active participant, a conscious being embedded in fields of force that extend from the quantum realm to the cosmic horizon. Your thoughts, your dreams, your very existence are woven into the invisible architecture that structures all of reality, making you not just a student of cosmic magnetism, but a living, breathing, thinking part of the magnetic cosmos itself. And as we drift deeper into this magnetic reverie, let's pause to consider one of the most intimate and quietly profound ways these invisible fields touch our existence through the remarkable magnetic memories that surround us in the most ordinary of places. Right now, as you rest in the gentle darkness, you're surrounded by a library of magnetic stories written in objects so commonplace you might never have considered their hidden electromagnetic narratives. That credit card resting in your wallet carries its information not in ink or print, but in microscopic patterns of magnetized particles arranged along a dark stripe. Each swipe through a card reader tells a magnetic tale: your account number, your name, your purchasing power, all encoded in the orientation of tiny iron oxide crystals suspended in resin. These magnetic memories can last for years, storing your financial identity in patterns of north and south that remain faithful long after you've forgotten the purchases they enabled. The hard drive humming quietly in your computer, if it still uses traditional magnetic storage, contains perhaps millions of your digital memories preserved as magnetic domains smaller than bacteria. Every photograph you've saved, every document you've written, every song in your music library exists as arrangements of magnetized regions on spinning aluminum platters. These microscopic magnets remember their orientations with startling fidelity, preserving your digital life in patterns that can be read and rewritten millions of times without losing their magnetic memory. But magnetic memory extends far beyond human technology. The rocks beneath your house, the bricks in your walls, the very soil in your garden all carry magnetic memories of Earth's ancient past. When volcanic rock cools from molten lava, magnetic minerals within it align themselves with the planet's magnetic field at that moment, freezing that orientation in place like a compass needle preserved in stone. These geological memories tell the story of our planet's magnetic wanderings over millions of years, recording pole reversals, field strength changes, and the slow drift of continents across the globe. The magnetic tape that once recorded your favorite songs, though now largely obsolete, represented one of humanity's most elegant partnerships with magnetic memory. Music, that most ethereal of human creations, was captured in patterns of magnetism that could be played back thousands of times, each playback recreating the original sound waves through the dance of magnetic particles past electromagnetic sensors. The emotional power of a symphony, the intimacy of a whispered love song, the energy of rock and roll, all preserved in the orientation of microscopic magnets on plastic tape. Even the aurora that occasionally grace our polar skies can be thought of as a form of magnetic memory made visible. When charged particles from the sun interact with Earth's magnetic field, they follow invisible pathways that remember the three-dimensional structure of our magnetosphere. Each shimmering curtain of light traces the memory of magnetic field lines, revealing the hidden architecture of forces that normally remain completely invisible to human eyes. The magnetic strips on old cassette tapes and VHS recordings created libraries of magnetic memories that defined entire generations. Families gathered around television sets to watch movies encoded in magnetic patterns on plastic ribbons, while teenagers created mixtapes that were literally love letters written in magnetism. The careful arrangement of magnetic domains could preserve a first dance, a graduation speech, a child's first words, human moments transformed into patterns of invisible force that could be retrieved and experienced again and again. Your smartphone's compass doesn't just point north, it remembers the magnetic character of every location you visit. As you move through the world, the device continuously samples the local magnetic environment, creating a map of magnetic memories that helps it understand your position and orientation. These magnetic fingerprints are so distinctive that your phone can often determine not just which building you're in, but which floor and which room, all by reading the unique magnetic signature of your surroundings. The magnetic memory of our planet extends into space through the solar wind, that stream of charged particles flowing outward from the sunday. These particles carry with them the magnetic field of our star, creating a vast magnetic bubble around the entire solar system called the heliosphere. This magnetic boundary remembers the sun's magnetic activity, preserving in its structure the history of solar storms, coronal mass ejections, and the 11-year solar cycle that governs our star's magnetic behavior. Ancient navigation tools like the magnetic compass created their own forms of magnetic memory. Sailors would carefully magnetize their compass needles by stroking them with lodestone, creating magnetic memories that would guide ships across trackless oceans for months or years. These simple magnetic memories, preserved in pieces of iron no larger than a needle, enabled the age of exploration and connected distant continents through trade routes that followed magnetic directions across the globe. The study of paleomagnetism, the magnetic memory preserved in ancient rocks, has revealed some of Earth's most dramatic secrets. Scientists can read the magnetic stories written in lava flows from millions of years ago, discovering that our planet's magnetic field has reversed its polarity hundreds of times throughout geological history. These magnetic memories tell tales of a dynamic planet where magnetic north became magnetic south and back again, creating a hidden chronology of Earth's magnetic evolution preserved in stone. Magnetic memory extends to the realm of the living through the magnetotactic bacteria we encountered earlier. These microscopic organisms contain chains of magnetite crystals that act as biological compasses, helping them navigate through sediments and water columns. Each bacterium carries within its cell a magnetic memory of Earth's field direction, passed down through generations of cell division like a hereditary compass that never loses its way. The magnetic fields of other planets preserve their own unique memories. Mars, having lost its global magnetic field billions of years ago, still retains magnetic memories frozen in its ancient crust. These remnant fields tell the story of a planet that once possessed a magnetic shield like Earth's, preserving in its rocks the memory of magnetic protection that could no longer deflect the solar wind from stripping away the Martian atmosphere. Even the cosmic rays that constantly shower our planet carry magnetic memories from their journeys across the galaxy. These high-energy particles, deflected and focused by magnetic fields throughout their travels, arrive at Earth bearing information about the magnetic environments they've encountered during voyages that may have lasted millions of years. Each cosmic ray particle is a messenger, carrying magnetic memories from distant stellar explosions, interstellar magnetic highways, and the magnetic boundaries of our solar system. The magnetic memory systems of the future promise to be even more remarkable. Scientists are developing quantum magnetic storage that could preserve information in the spin states of individual electrons, creating magnetic memories so dense that the entire contents of the Library of Congress could be stored in a device smaller than a grain of sand. These quantum magnetic memories would be nearly indestructible, capable of preserving information for geological timescales without degradation. Biological magnetic memories continue to surprise researchers with their sophistication. Sea turtles appear to carry magnetic maps of entire ocean basins, remembering not just directions but the subtle variations in field strength and inclination that create unique magnetic signatures for different locations. A turtle hatching on a beach in Florida somehow remembers a magnetic map of the Atlantic Ocean detailed enough to guide it on migrations covering thousands of miles over many years. The magnetic memory of our galaxy extends far beyond our solar system, through the cosmic web of magnetic fields that thread through interstellar space. These galactic magnetic memories preserve information about stellar formation, supernova explosions, and the gravitational interactions that have shaped our corner of the universe over billions of years. The spiral structure of the Milky Way itself may be partially maintained by magnetic memories encoded in the interstellar medium. As we venture into an era of magnetic levitation trains, quantum computers, and fusion reactors, we're creating new forms of technological magnetic memory that would have seemed impossible just decades ago. Superconducting magnetic energy storage systems can remember enormous amounts of electrical energy in the form of persistent current loops, creating magnetic batteries that could store power for months without loss. These systems remember energy in patterns of magnetic flux that persist as long as the superconducting materials remain cold. The magnetic memory embedded in your surroundings extends to scales both intimate and cosmic. The iron in your blood carries weak magnetic memories of the foods you've eaten and the environments you've lived in. The magnetic minerals in the dust settling on your windowsill remember the industrial processes, vehicle emissions, and natural sources that created them. Even the magnetic field of Earth itself remembers the solar storms that have battered our planet over the centuries, preserving their signatures in the slowly changing patterns of magnetic declination recorded by navigators and surveyors. Magnetic memory also operates in ways that transcend individual objects or locations. The collective magnetic behavior of materials can create emergent memories that arise from the interactions between countless microscopic magnetic domains. These collective magnetic memories can exhibit properties like hysteresis, where the magnetic state depends not just on current conditions but on the history of magnetic fields the material has experienced. The aurora themselves create temporary magnetic memories in Earth's upper atmosphere, ionizing gases in patterns that can persist for hours after the original magnetic disturbance has passed. These atmospheric magnetic memories can affect radio wave propagation, creating communication conditions that remember the ghost of geomagnetic storms long after the charged particles from space have dissipated. As you rest there in the quiet darkness, surrounded by layers upon layers of magnetic memory, consider that these invisible recordings connect you to every scale of cosmic history. From the magnetic memory in your smartphone that remembers your favorite locations to the magnetic memories in rocks that preserve Earth's ancient field reversals, from the magnetic memories in cosmic rays that carry information from distant galaxies, to the magnetic memories in your own body that record your biological history, you exist within a universe that remembers itself through magnetism. These magnetic memories don't just store information, they create continuity between past and present, connecting moments separated by microseconds to epochs spanning millions of years. They're the universe's way of maintaining coherence across time, ensuring that the patterns and structures created by magnetic forces persist long enough to influence future events and developments. The most profound realization might be that consciousness itself could be understood as a form of magnetic memory. The electrical activity in your brain creates magnetic fields that encode your thoughts, experiences, and memories in patterns that persist and evolve over time. Your ability to remember these words, to contemplate the mysteries of cosmic magnetism, to feel connected to the vast magnetic tapestry of the universe, might all be manifestations of magnetic memory operating at the scale of neural networks and electromagnetic fields generated by living tissue. So as you drift towards sleep, carried along by the gentle current of these magnetic meditations, remember that you're not just surrounded by magnetic fields, you're immersed in magnetic memories that connect every moment of existence to the grand, ongoing story of cosmic evolution. These invisible records preserve the history of stars, planets, and consciousness itself, creating an electromagnetic archive that spans from the quantum realm to the cosmic web, ensuring that nothing in this magnetic universe is ever truly forgotten. The magnetic memories flowing through space around you tonight carry echoes of the Big Bang, whispers from dying stars, and the dreams of future civilizations yet to be born. In this vast library of magnetic memory, every field line is a story, every domain reversal, a chapter, and every moment of your conscious experience, a new entry in the endless electromagnetic chronicle of existence itself. And as we come to the gentle close of our journey through the invisible architecture of the cosmos, let us float quietly back to where we began with you, resting peacefully in a space that now feels transformed by understanding. When we started, you were simply lying in a room, perhaps feeling the weight of the day settling into your shoulders, listening to words about forces you couldn't see. Now, I hope that same space feels different, alive with invisible currents, threaded with field lines that connect you to every corner of the universe. The magnetic fields we've explored tonight aren't just abstract scientific concepts or distant cosmic curiosities. They're intimate companions that have shaped every moment of your existence. The oxygen you're breathing was forged in stellar cores and scattered by magnetic processes in dying stars. The iron flowing through your veins carries the magnetic signature of ancient supernovae. The very neurons firing in your brain as you process these thoughts create tiny magnetic fields that ripple outward into space, adding your consciousness to the vast electromagnetic symphony that surrounds us all. Think about how remarkable this is, that invisible forces operating according to elegant mathematical laws can create such beauty, such complexity, such meaning. From the simple attraction between magnets that delighted you as a child, to the magnificent spiral arms of galaxies shaped by cosmic magnetic highways, from the aurora dancing in polar skies to the quantum magnetic states that enable the technology surrounding you, magnetism reveals itself as both utterly alien and deeply familiar, both impossibly vast and surprisingly intimate. The invisible architects we've encountered tonight work on every conceivable scale. They guide the migration of sea turtles across ocean basins and the formation of galaxy clusters across cosmic voids. They preserve memories in the rocks beneath your feet and in the hard drives storing your digital life. They protect our planet from harmful radiation while enabling the northern lights that have inspired human wonder for millennia. They power the devices that connect us to each other and the generators that illuminate our nights. What strikes me as most beautiful about magnetic fields is their patient persistence. They operate without fanfare, without visible drama, yet they never rest. Right now, as you listen to these words, Earth's magnetic field is deflecting charged particles from space. The sun's magnetic field is guiding plasma through solar flares, and the galaxy's magnetic field is channeling cosmic rays on journeys that span millions of years. These invisible forces have been working since before the first life appeared on Earth, and they'll continue long after the last star burns out in the distant future. There's something profoundly comforting in this constancy, this quiet reliability of magnetic forces. In a world that often feels chaotic and unpredictable, magnetism provides a steady background rhythm field lines that maintain their orientations, compasses that point toward magnetic north, Aurora that appear when solar storms interact with Earth's magnetosphere, according to laws we can understand and predict. These invisible threads create order from apparent randomness, structure from seeming chaos. The story of magnetism is also the story of human curiosity and ingenuity. From ancient sailors using lodestone to find their way across unknown seas to modern physicists probing the quantum nature of magnetic materials, we've gradually learned to see, understand, and harness these invisible forces. Each generation has pushed the boundaries of what's possible with magnetism, from simple compass needles to magnetic levitation trains, from mechanical generators to quantum computers that manipulate magnetic spin states. Yet for all our technological mastery, magnetism retains an essential mystery that continues to inspire wonder. We can describe precisely how magnetic fields behave, we can predict their effects with remarkable accuracy, but the deeper question, why do these forces exist at all, remains beautifully unanswered. Magnetism, like consciousness itself, emerges from the fundamental structure of reality in ways that feel both inevitable and miraculous. Perhaps that's the most profound lesson from our journey tonight, that we live in a universe where invisible forces create visible beauty, where mathematical laws give rise to aurora and galaxies and consciousness itself. The magnetic fields threading through space around you are proof that reality extends far beyond what our senses can directly perceive, that there are layers upon layers of hidden structure underlying the everyday world we think we know so well. As you settle deeper into rest, carried along by these magnetic meditations, remember that you're not separate from the cosmic forces we've explored. You're part of them. The magnetic field lines flowing through your room right now connect you to the molten iron in Earth's core, to the plasma storms on the Sun, to the spiral structure of our galaxy, and ultimately to the vast network of magnetic highways that spans the observable universe. In this interconnected magnetic cosmos, every particle in your body participates in the grand electromagnetic dance that has been unfolding since the first moments after the Big Bang. Your thoughts create magnetic fields, your movements disturb magnetic environments, your very existence adds to the complex patterns of electromagnetic activity that characterize our corner of the universe. So tonight, as magnetic fields guide charged particles through Earth's magnetosphere high above your head, as your compass needle points faithfully toward magnetic north, as the aurora perhaps dance unseen in polar skies, rest in the knowledge that you're embraced by invisible forces that connect all things. The universe is not a cold, empty void punctuated by isolated islands of matter and energy. It's a warm, interconnected web of electromagnetic relationships that link every atom to every other atom, every moment to every other moment, every consciousness to the cosmic whole. The invisible cosmic architects we've explored tonight don't just build galaxies and guide planets. They create the very possibility of meaning, of connection, of the kind of wonder you might be feeling right now. They remind us that reality is far stranger, far more beautiful, and far more intimately connected than we could ever imagine from our limited human perspective. These invisible threads that weave through your space carry with them a promise that exploration never truly ends, that wonder always awaits just beyond the edge of what we think we understand. Tomorrow, scientists will discover new magnetic phenomena in distant galaxies. Next year, engineers will find new ways to harness magnetic forces for human benefit. In decades to come, we might unlock magnetic technologies that seem like magic to us today, just as MRI scanners and wireless charging would have seemed like sorcery to our ancestors, who first noticed lodestone attracting iron. The magnetic universe we've explored tonight is still revealing its secrets. Deep space telescopes are detecting magnetic fields in places we never expected to find them. Quantum physicists are discovering magnetic behaviors that challenge our fundamental understanding of matter and energy. Biologists are uncovering magnetic senses in creatures we thought navigated by sight and smell alone. Each discovery adds another layer to the magnificent tapestry of cosmic magnetism, revealing new connections, new patterns, new reasons for quiet amazement. And yet, perhaps the most remarkable thing about magnetic fields is how they make the impossible seem effortless. A compass needle weighing fractions of an ounce responds to a magnetic field generated by molten iron thousands of miles below the surface. A tiny bacterium navigates murky sediments using magnetic crystals smaller than viruses. A spacecraft, millions of miles from Earth, adjusts its orientation using magnetic torques that interact with the solar wind. These everyday miracles happen so smoothly, so reliably, that we forget how extraordinary they truly are. There's poetry in this invisible precision, the way magnetic field lines curve through space with mathematical elegance, the way Aurora follow these curves to paint the polar skies, the way your phone's compass finds north by sensing forces that have travelled from the planet's core to your palm. Every magnetic interaction, from the quantum scale to the cosmic scale, follows the same fundamental principles discovered by curious humans with simple magnets and coils of wire. As you drift now toward that peaceful boundary between waking and dreaming, let yourself be carried by the knowledge that you're part of something magnificent and ongoing. The magnetic fields surrounding you tonight have been flowing for billions of years, and they'll continue for billions more. They've witnessed the birth of stars, the formation of planets, the emergence of life, the rise of consciousness. They've guided ancient migrations, enabled human exploration, and now support the technology that connects our modern world. In your dreams tonight, perhaps you'll find yourself floating along magnetic field lines, riding invisible currents from Earth's core to the edge of the solar system and beyond. Perhaps you'll sense the gentle tug of magnetic forces that normally remain below the threshold of perception, feel the vast electromagnetic web that connects every atom in your body to every star in the sky. Perhaps you'll experience, in that wordless way of dreams, the profound truth we've explored tonight, that nothing in this universe exists in isolation, that everything is connected through invisible threads of force that bind the cosmos into one magnificent, ever-evolving whole. The invisible cosmic architects will continue their patient work while you sleep, shaping space and time with the same quiet persistence they've shown since the universe began. Field lines will curve through the darkness, charged particles will spiral along magnetic highways, and somewhere in the vast reaches of space, new magnetic phenomena will unfold that future generations will marvel at and study and eventually understand. But for now, as this gentle journey through the magnetic cosmos draws to its close, know that you carry within you a deeper appreciation for the hidden forces that shape reality. Every time you use a compass, every time you see the aurora in a photograph, every time you charge your phone wirelessly or watch a speaker cone vibrate to create sound, you'll remember that these everyday technologies are manifestations of cosmic forces operating according to laws that govern everything from quantum particles to galaxy clusters. Thank you for joining me on this quiet exploration of the invisible architecture that surrounds us. If you've found peace in these magnetic meditations, if you've discovered wonder in the hidden connections that link all things, please consider sharing this journey with others who might benefit from a gentle reminder that we live in a universe far more beautiful and interconnected than it appears. Whether you're listening from a bedroom in Berlin at 3 a.m, a living room in Los Angeles as the sun sets, or anywhere else in this magnificently magnetic world, you're welcome here. Sleep well, dream deeply, and remember that you rest tonight in the embrace of invisible forces that connect you to every other conscious being in the cosmos, all of us floating together through space on a planet protected by magnetic fields, warmed by a magnetically active star, in a galaxy threaded with invisible currents that have been flowing since before time had meaning. The universe is vast, mysterious, and beautiful, and you, dear listener, are an integral part of its story. Good night.